20.3 hints for another 3 homework questions. Question number 20 through number 22. Yeah. Question number 20 about Tower of Hanoi problem. Yeah. For this one here, I ask you, I solve it for 2 different cases. Now, the first one, we use M1 disks. Then by our standard solution, we need to make M1 moves. Second time, we change the problem to N2 disks, and we make M2 moves. Then I tell you M1 plus M2 equals 2174. Yeah. Then also we know M2 greater than M1. Then I ask you the pair of numbers N1 and N2. Yeah. So this question is not very hard. You only need to use the formula for a relationship between N and M. Yeah. All right, so here let's use N, the number of disks. Okay, M, number of moves, right? Yeah. And we have the relationship M equals 2 to the nth minus 1. The formula we derived. Now it's easy. So we have M1 equals 2 to the N1 minus 1. M2 equals 2 to the N2 minus 1. All right? Yeah. And M1 plus M2 equals 2174. All right? After that, can you solve the pair N1 and N2? Right? Yeah. Try to, use some special properties of numbers, integers, to get a solution. Yeah. The solution is unique. Yeah. All right, so that is the question number 20. Next one, number 21, Horner's rule problem, right? But here, I ask you only the number of additions. In other words, we need to count number of plus signs, right? Yeah. So what we need to do, we need to count number of plus sign. All right? Yeah. The method we use in the lecture, I introduce a special counting technique or basic counting technique. So that is count by reference. Yeah. So you need to find special reference. Then you convert your counting problem on counting another different type of objects. And that counting, new counting, is much easier than the original counting. That's the basic idea. All right. So here, when you count the number of plus sign, the obvious way, so you can think about, you can associate each plus sign to a subscript or superscript, right? 2 possibilities. But here I give you the subscript, superscript, or exponent numbers following different rules. So I tried to trick you a little bit. Yeah. So the references here, you can consider the references. Yeah. One is subscripts. Another superscripts. Okay. Subscripts, you need to list all of them, try to find some rule. 4, 7, right? 10, ... 502. Superscripts, you list them. 5, 9, 13, ... 669. Okay, yeah. But you only need to one of the two. Okay, yeah. Only need to use one of the two. Yeah. Not necessarily both. One is enough, right? Yeah. And here you can see for subscripts, the difference between two adjacent subscript 3, right? Difference between two adjacent 3. Okay. Superscript, the difference between two adjacent 4. Right? Yeah. 4. Right. Yeah. Oh, sorry. There's 3 here. Yeah. And you, based on that observation, try to count the number of subscripts or number of superscripts. Then you get answer number of additions. Yeah. Yeah. Just check your, if you can use our technique, count by reference technique. Yeah. All right. Question number 22, given an array with n elements and greater than 2. It is known that this array is not sorted. Not sorted. Okay? What is the maximum number of possible elements that are in place? All right? Yeah. So for this question, actually I gave you similar question before. Yeah. The question in the quiz 2, question number 1, we did that. Yeah. So you can find, I also post a video explain that question. Yeah. So you can look at that another time. Yeah. But here, in order to answer this question, yeah, because if it is not sorted, we can get a maximum number cannot be n, right? Cannot be n. Yeah. Otherwise, it will be sorted, right? Otherwise, you will get contradiction. Okay. To not sorted. Right? So cannot be n elements in place. All right, so that's the easy part. Okay. Then next one, is it possible to have n minus 1 elements in place? Right? Yeah. Possible or not? Then this question will tell you that. Okay? Our quiz question will tell you if n minus 1 elements in place is possible or not. Okay? All right. So then after that, look at n minus 2 possible. Possible or not. Right? To see n minus 2 possible. All right. So because you may not be able to find contradiction, right? Yeah. You may not be able to find contradiction. Yeah. For n minus 2, if you cannot find a contradiction, yeah, can you construct an example to show that n minus 2 is possible. N minus 2 elements in place is possible. Yeah. Just with simple example. A simple example is enough to show it is possible. All right? Yeah. You know, thinking in this way, so then you can answer this question easily. Yeah. All right, so let me stop here. Then I have the last video, you know, to complete all the hints. All right.